Nature endowed a great continent with a bounteous supply of natural resources. Here, with the aid of these resources, 170 million people are creating a great social and industrial community. New manufacturing plants stand as proof of an industrious people in the workshop of the free world. New houses, more than 1 million each year, provide dwellings for a constantly increasing population. And here, just as we share the fruits of nature's bounty, we also share in the problems of our social development. For with the expansion of our industry and the great personal use of water by our people, we share in a nationwide shortage of readily available water. Water, greater than gold, to our continued way of life. For the basic necessities of life are in the air we breathe, the food we eat, and the water we drink. Water is essential in building strong, agile bodies through healthy recreational activities, and to care for the chores that are part of the beautiful and comfortable life of an ever-increasing population. But throughout the nation, the use of water, an average of 150 gallons per day per person, has called for us to face a serious shortage of nearby water. On the East Coast, New York found a partial solution in large pipelines to watersheds far to the north. On the shores of the Great Pacific, Los Angeles found it necessary to go long distances to meet the demands of a fast-growing population. And the selection of busy and prosperous Colorado Springs as the home of the Air Force Academy emphasized a need that Colorado Springs had been aware of for many years. The supply of water from Pikes Peak had cared for their needs, but now with the community growth accented, it became necessary to look beyond their present water sources to the Continental Divide. At this point, looking south, water on the eastern slope flows toward the Atlantic Ocean, and water on the western slope flows to the Pacific. Through the mighty divide, a tunnel 2 miles long was bored to carry western slope water under the Hoosier Pass and deliver it to the eastern slope through a large spillway. From there, along and through this rugged terrain, the water will rush for 100 miles, dropping more than 4,000 feet to Colorado Springs, which is 6,000 feet above sea level. The water will be transported through strong steel pipe, which can easily handle the 800 pounds pressure per square inch, and yet is relatively light. Steel pipe was selected by Colorado Springs because of their past successful experiences. Way back in 1924, they laid a 20-inch steel pipeline on the rugged south slope of Pikes Peak and learned many things about steel pipe that helps them today in their race against time. They learned about the beam strength of steel pipe. It only requires a minimum amount of support over ravines or big gullies. They learned how easily and quickly it can be installed with flexible tight couplings, up and down hill and around curves with straight pipe sections. From Lake Moraine, the steel line delivers and will continue to deliver its design capacity all the way down through Ute Pass, Manitou Springs, and into the city distribution system. Water on the north slope of Pikes Peak was gathered and stored in 1933. And again, Colorado Springs used steel pipelines to connect 2 large reservoirs, boosting their system storage capacity to over 12,000 acre-feet of water. Experience proved that steel pipe, lined and coated with coal tar enamel and coupled with flexible couplings, offered permanent protection against breaks or bad leaks. Steel pipe delivers millions of gallons daily, and the residents of Colorado Springs can serenely enjoy life free of the worry that cave-ins or floods might cause service interruptions. So when the time came to start thinking about tapping the waters of the distant Continental Divide, the engineers knew what they wanted. Black & Veatch, the consulting engineers, designed the system in 3 stages. They knew what they could count on with the design, installation, and performance of steel water pipe. They could get the widest range of sizes and shapes for design flexibility to meet any present or future problems. Every length of pipe would be hydrostatically tested before shipment to assure its ability to withstand high operating pressures. The first stage of the job was to collect water on the western slopes, on the 10,000 acres beyond the divide, where Colorado Springs had bought water rights, mostly abandoned gold mining claims. Work began to collect the water and divert its flow to the entrance to Hoosier Tunnel. Collection ditches, dams, and spillways were built to deliver water to 3 steel pipelines feeding the tunnel. Their smooth, shiny lining of coal tar enamel ensures a high capacity for water flow from now on. This is the Quandary Mountain Line. On the steep grade, shorter lengths of straight steel pipe and flexible couplings adjusted the line to the rugged terrain. Only a small crew was used to lay the line, and the only tools required to join the pipe lengths were 2 torque wrenches. All 3 steel pipelines, protected inside and outside with coal tar enamel, will deliver their western slope water into Hoosier Tunnel. Out the other end of the tunnel, the water flows down the eastern slope. As a temporary measure, flow was diverted into the middle fork of the South Platte River, which flows into 11 Mile Canyon Reservoir. This is part of Denver's water system, and arrangements were made for storage of Colorado Springs water until needed, when it was released to flow along the river to Lake George. Thus, Lake George on the eastern side of the Continental Divide became a temporary reservoir for western slope water. The second stage of the project was to get this water from Lake George into the Colorado Springs reservoir system on Pikes Peak. This stage of the system was built in 1952. Even though this pipeline was to be the delivery end for all the western slope water collected and would eventually deliver 18 million gallons per day, they did not over-design because they knew there would be no reduction in flow from leakage, tuberculation, and encrustation. The 30-inch steel pipe, lined and coated with durable coal tar enamel and joined with bottle-tight flexible couplings, will continue to perform like a 20-mile-long shotgun barrel. So Colorado Springs proceeded with the Montgomery Dam project, the third stage in their planning, with a confidence born of their past satisfactory experience. This area will provide a tremendous reservoir for the western slope water from Hoosier Tunnel. The water will be impounded by a rock-filled dam 2,000 feet long. But the biggest job of all was to build the 53-mile-long pipeline from Montgomery Reservoir to the connecting pipeline built from Lake George in 1952. And time was critical, particularly because of the impending opening of the Air Academy. The pipeline had to be built with speed and economy, but most of all, it had to be built to last. The line would be made of tough, long-lasting steel, of course, with every piece tested for twice the normal operating pressure before it left the pipe mill. The pipe would be lined and coated with the finest coal tar enamel for maximum corrosion protection and covered with a reinforcing wrap. The coal tar enamel lining ensures the purity of the water and delivery of maximum free flow capacity indefinitely. These 40-foot lengths of steel pipe would be easily transported to the pipe laying operations began with surveying, staking out the line, and clearing the right-of-way. A ditcher chewed a narrow trench only 42 inches wide and about 7 feet deep, piling the earth in a neat windrow as it opened mile after mile of ditch. Just part of the array of modern equipment used by the R.H. Fulton Company. Next, the backhoes came, clearing the trench of rocks and stones to provide a uniform ditch bottom and also cutting bell holes to permit coupling the pipe in the ditch. More than 7,000 lengths of steel pipe were required. Even though computed operating pressures were extremely high, minimum 240 to maximum 850 pounds, most of the line has a wall thickness of only 1/4 inch. A pipe wall of 0.507 inches was used for the maximum pressure. On this 1,700-acre tract, in the middle of South Park and miles away from civilization, the Koppers Company, manufacturers of bitumastic 70B coal tar enamel, set up one of its complete field coating plants to prepare the pipe according to specifications with straight-line production efficiency. It was manned chiefly by local labor. The first step in complete corrosion protection is to thoroughly clean the pipe so the coal tar primer will adhere to the metal. The cleaning and prime coating operation to give the steel pipe lifelong protection is finished here in less than 2 minutes. The primed pipe is now ready for the hot enamel coating. Scientists agree when no moisture comes in contact with steel, no corrosion occurs. There is no more waterproof coating known to science. It's been proved by more than 100 years of service, protecting iron and steel surfaces underground, underwater, even immersed in salt water. The wrap gives additional strength and toughness to the coating. The tough adhesive coating means permanent protection and long life for the steel water line. The next step to prepare the pipe takes place at the sandblasting station. The interior of the pipe is prepared by sandblasting. The result will be perfectly clean metal ready to form a lasting bond with the coal tar enamel lining. Every inch of the pipe interior is then covered with the coal tar primer. Of all the production magic in these wide open spaces, the next step, the spinning of the smooth, ebony-like final lining, is the most amazing. Long troughs filled with coal tar enamel are moved into the spinning pipe. The correct amount of coal tar enamel is applied at just the right speed and temperature to form a perfectly smooth, polished black surface for carrying water. The black armor lining will prevent encrustation and tuberculation. No leaching takes place to rob life from the lining and affect the quality of the water. Design and consulting engineers specify this smooth coal tar enamel because they know it will retain its high Hazen and Williams flow coefficient indefinitely. Only 3/32 of an inch thick, there is little diameter encroachment to affect the capacity. The high flow coefficient and minimum encroachment mean savings in pipe diameter and operating costs. A special electrical test using 10,000 volts is made to ensure that every inch of the pipe is properly lined and coated. Frequent tests are also made of the tough, durable coating on the exterior of the pipe. Here, the inspector cuts into the coal tar enamel to check its bond strength. Within minutes after the final thermosetting enamel lining is applied, the pipe is ready for installation. Coal tar enamel has been used successfully on thousands of miles of water, natural gas, and petroleum pipe. A total of 240 feet of pipe in one truckload. At the ditch, the 40-foot lengths of steel pipe are quickly and easily unloaded because steel pipe weighs only 1/5 as much as cast iron and only 1/6 as much as concrete. Only straight lengths of pipe were shipped to this job because pipe bends up to 20 degrees were made right on the job, without injury to the smooth coal tar enamel lining. The ability to make pipe bends in the field saves both time and money. Gradual bends are usually made in the field with flexible couplings. To prepare for coupling the pipe ends, the follower ring, gasket, and middle ring are mounted on one end of the pipe. On the other end, the other follower ring and gasket are also set in place. Then a small side boom tractor picks up the pipe using a special rubber-covered belt sling to protect the coating and carefully lowers the pipe into the ditch. Note how easily the pipe ends are stabbed into the coupling. No time-consuming lineup problems are involved. As the pipe ends come together inside the middle ring, the joining crew quickly slides the two gaskets and follower rings in place. Now the coupling is ready to be bolted, forming a uniformly tight, flexible joint that is stronger than the pipe itself. It will remain tight indefinitely because rubber under compression does not wear out, especially when buried underground where it's protected from its natural enemies of light, heat, and air. The four-man crew with electric wrenches will make up a coupling in about 2 minutes. The speed of coupling installation was another important factor in the completion of this 53-mile line at the record rate of approximately 4,200 feet per day. Following the first pipe joining crew are several two-man teams, pulling up the bolts to 85 foot-pounds with torque wrenches. Two average local workers without special training or trade can quickly and easily make up a perfect joint every time using only wrenches. Bad weather is no handicap, and joints can be made up even underwater when necessary. Design engineers and consulting engineers specify couplings because the entire joint is made up outside the pipe. There are no projections inside or roughness to reduce the flow characteristics of the smooth enamel-lined pipe, and no heat of any kind is used, which could possibly harm the lining. A spot check of the bolts is made by the foreman with a torque wrench prior to approval of the joint. The coupling is given a thorough coating of coal tar enamel, then both pipe ends carefully wrapped right up to the coupling itself. With coupled steel water lines, low accurate costs can be predicted, and on-time completion dates are assured even on a big job like this one. Watertight joints can be made by local labor as fast as the pipe can be lowered into the ditch. Just as coated and coupled steel pipe wound its way from Lake Moraine in 1924, up the steep slope of Pikes Peak in 1933, through the rugged terrain from Lake George in 1952, it now reaches out to the Continental Divide to bring vitally needed water over a tortuous 100-mile route to Colorado Springs. Overcoming vertical and horizontal deflections is all in a day's work for steel pipe and couplings. Backfilling begins after each section of the line is checked and approved by the consulting engineers. Then the right-of-way is cleaned up. Fences are replaced, as in this scene, where the pipeline went right through this farmyard. Starting on April 20th at Lake George, 53 miles of steel water line were laid by July 21st. About 280,000 feet during the 68-day period, despite the rugged terrain. This average of approximately 4,200 feet per day is a remarkable achievement and a tribute to the superior qualities of steel pipe and the methods employed by the contractor, R.H. Fulton Company. When Montgomery project is completed, more than 18 million gallons of water per day will flow out of the Hoosier Tunnel. This water will be contained for approximately 73 miles in strong steel pipe. The smooth bitumastic 70B enamel lining assures the highest possible flow coefficient, and the dresser couplings provide bottle-tight construction to assure Colorado Springs an abundant supply of health-giving water for every human need. Even the farmers along Fountain Creek below Colorado Springs will receive a real bonanza, because from 8 to 10 million more gallons of water per day will be available to irrigate their crops. Colorado has great mineral wealth, leading all other states in the production of tin, molybdenum, and vital uranium, and producing more than $4 million worth of silver and $12 million worth of gold each year. But more important is their water development program. When it's completed, they will be able to store a 2-year supply of water, a truly remarkable program of progressive water development for the future growth of their community. Certainly, the Colorado Springs officials of today and of the past deserve a full share of credit for a job well done. And the managers, superintendents, engineers, employees, and consulting engineers of the present and the past contributed in full measure. There's credit enough for all who helped, including the manufacturers of the pipe, couplings, coatings, and tools, the contractors, and the workers down through the years who brought the people of Colorado Springs something truly greater than gold.